Hey, hello and welcome to today's GFG problem of the day. Hope you're doing well. So let's see today's problem, search pattern KMP algorithm. Okay, so what the problem is saying is we'll be given two strings. One is a text string txt and the other is a pattern string pat. The task is to print the indexes of all the occurrences of pattern string in the text string. And we want to use zero-based indexing while returning the indices. Okay, so here let's see through an example what the problem is trying to tell us. So we'll be given a text string and we'll be given a pattern string. So what we want to do is we want to find out all the occurrences of the pattern string into this particular text string. Okay, and we want to return the starting indices of those occurrences. Okay, so here pattern is the first occurrence is here, right? The first occurrence is here. So what is the starting index of this occurrence? It is 0, right? This is 0th position. Okay, then second occurrence is here. Okay, so what is the starting index of this occurrence? 0, 1, 2, 3, 3. So 3. So we want to return the starting indices of all the occurrences of pattern in the text string. Okay, so I hope the problem is clear. Now, how can we solve this problem? So first of all, let's see the brute force approach. Okay, so what we're going to do is we'll have two pointers here. One will be I and second will be J. Okay, so we are going to match. Is I is text is pattern is this part of J, is it equal to text of I? Yes, it is. So we are going to increment both the pointers. Okay, both the pointers. Is it matching? I and J, yes, they are matching. So we have found a match. We'll increment again I and J, right? So we have found a match here. We are going to stop since J has exhausted basically. It has gone beyond the length of the pattern string. So here we have found the match AB, AB. So we are going to record the starting index of this particular text. Okay. Then what we are going to do? So since we have exhausted J, we are going to reinitialize J and will point here. Okay. And again reinitialize I so that it will point here. Okay. I will point here. Again, we are going to check here. Is J this is and this is it matching? No, it is not matching. We're going to increment I. Okay, is this and this matching? No, it is not matching. We're going to increment I. Right, is this and this matching? Yes, they are matching. Okay, then we are going to increment both I and J. I is here, J is here. B and B are they matching? Yes, they are matching. So we have found another occurrence and we are going to whatever the starting index, right? So we are going to add here and we are going to solve the problem. But here the time complexity is going to be what? So what we are simply doing is we are again, first of all, if so, for example, if there is a match, okay, we are going all together to previous index, right? For example, here I was here, right? So we are going back again and restarting from there. Okay, so the time complexity for this it is going to be O of n into m. Okay, O of n into m. N is a text, the size of the text, and m is the size of the pattern. Okay, so almost it is like O of n into m. Okay, so let's quickly see. Now we'll see the optimized approach, right? The better approach than this one. Okay, so for this, let's take this particular example, text and pattern. Okay, this particular example. Okay, now that optimized approach, it is going to be KMP algorithm. Okay, KMP algorithm. So let's see what KMP algorithm has to say. So in KMP algorithm, what we generally do is we create a longest prefix array. Okay, longest prefix subarray. Okay, we can say longest prefix subarray. So what it means is, so the size of the array will be the size of the pattern string. Okay, for example, we'll see what it is. Okay, okay. So what do we do here? So we find out the longest prefix, okay, which matches the longest suffix, which matches the suffix. So we are going to find out the longest prefix which also matches the suffix. For example, here. So we are going to have two pointers here. Okay, one will be len, the pointer name will be len, and there will be I, which is be starting from here. Okay, I will be starting from here. Okay. Now, what we're going to do is we're going to compare I and this I, the character at I position and the character at O position. Are they matching? So before that, we will initialize our LPS, the position, right, with 0. Saying that for only one character, we are going to assume for only one character, the longest prefix and the longest suffix, it is going to be 0. Okay. Post that, we are going to start our I will be pointing here, our len will be pointing here. We are going to compare the two characters. Are they matching? No, it is not matching. Then we are going to initialize 0. Okay. Then we are going to increment our I. Len will be there only. We are going to increment our I. I will be pointing here. We are going to check, is this the characters matching? No, they are not matching. It will be 0. Okay, we'll increment our I. Now I is pointing at this position and len is pointing at this position. So we are going to compare both. Yes, both the characters are matching. So what we are going to do is we are going to add len plus 1 here. Okay, len plus 1. So which is len is 0, right? It is at 0th position, right? It is at 0th position. 0 plus 1, 1. So what we are saying is, if you can see, right, O and O, they both are matching. What is the size of the prefix? It is 1 because it's a single character O, right? O and O, right? It is matching. Then we are going to increment both. When the character matches, we are going to increment both our len. Len will be pointing here and our I will be pointing here. Now we're going to compare again n and n. Are they matching? Yes, they are matching. So what are we going to do here? So we are going to do len plus 1. So len, where it is pointing right now, it is pointing at one position. Len, okay, right? So len plus 1, 1 plus 1, 2. So here we are saying 2. So what we are saying here is, so this means the longest prefix size is 2. That means the two characters, the prefix is 2 and the suffix is 2 for this particular substring. For this particular substring, the longest prefix, which is also matching the suffix, is 2. So which is here. Okay. Okay. So here we have written 2. Now comes S here. So again, we are going to increment I and len as well. Len is here. So we're going to compare S and I. They are not matching. We are going to add 0 here. Okay. So this is our LPS array. Okay. Now you'll know why we have calculated this LPS array. Okay. In just a few minutes. Okay. In just few minutes. Okay. So here. So again, let's write. Text is what? Text is here. Text N I O N I O N S L, right? And what is pattern? Pattern is O N I O N S. Okay. So here, what we're going to do here is we're going to have a J pointer here. Sorry, not J pointer. Let's have I pointer here. I pointer, and here we'll have a J pointer. Okay. Now what we're going to do? We are going to compare both the characters at both positions, I and J. Yes, they are matching. So then what are we going to do? We are going to increment I and J both. I and J. Right? We're going to compare again. Yes, they both are matching. So we're going to increment I and J again. Both are matching. Yes, we're going to increment I and J. Right? Both are matching. Here both are both are matching here. We're going to increment I and J. Right? Both are matching. We're going to increment I and J. I and J. Right? Now, are these two characters matching? No, they are not matching. Okay, that means we have not found the pattern match as of yet. Okay, so these both characters are not matching. So in the earlier approach, what we would have done in the earlier approach, we would have reset this J back to this here. Okay, back to this particular position, and our I would have started from here, N position, all the way back to this second position, right? And J would have started from here, and we would have started comparing again like this, right? So that was a brute force approach. That was a previous approach. But let's see in this approach how it is optimized. Okay, so let's come back here. So both characters are not matching. So in this case, what we're going to do? What does this mean? So at least the previous characters, right? The previous string, this and this, they got matched, right? This and this, they got matched. Okay, so now comes the LPS array into picture. Okay, what is LPS? Let's write here also. Let's write here. So this is our LPS array, right? This is our LPS array. And how does it look like? 0, let's write 0, 0, 1, 2, and 0, right? This was our LPS array, right? Now what we are saying is, do we have a suffix, right? So this is a suffix, right? We can say this is a suffix, right? This is a suffix, we can say this. Okay, so do we have a longest suffix? Do we have a longest suffix which is also as a prefix, for example? So how we are going to see that? So this is the current position, right? So we're going to check here before the character which was matched. So do we have a longest suffix? If you see here, right? How we are going to check here? So here it is. So yes, it is saying this, our LPS array is saying, yes, we have a longest suffix or prefix of size 2. So what does this mean of size 2? This means that this suffix, it is already matching with this particular prefix. That's what it was saying, right? That's what we were saying, right? This particular suffix, it is matching with prefix. This and this we can consider same. This and this we can consider same. So what we are saying is, this particular suffix, it is matching with this particular prefix. So we don't have to go all the way. We don't have to reset our j all the way to here. Okay. So what it is saying is we have to start our j with pat of 2 position of this particular pat of 2. That is what is 2? 0, 1 and 2. Okay. So we have to start our j. We have to reset our j from here because what we are saying is the last two characters are already matched, we can say, with the pattern. The last two characters are already matched with the first two characters. So let's our I will be here only pointing here and our j will be pointing here rather than here, right? Rather than here, not here. Our j will be pointing here. Okay, because these characters they are already matching. That's what our LPS array is saying. Okay, because how it is saying because of the longest prefix, right? That's what we calculated. What is the longest prefix which is also which matches a suffix? So it was here, and here and they are already matching, right? So we are saying the longest suffix is yes, which is matching with prefix. So let's start with this particular. Aj will start with here. Now we'll compare I and j. Yes, they are matching. Yes, they are matching. So we are going to increment our I and j. Right now j is pointing here. Right? Are these characters matching? Yes, they are matching. We'll increment I and j. Right? Are the two characters matching? Yes, they are matching. We'll increment our I and j. J pointing here. Are these two characters matching? Yes, they are matching. So we have found a pattern match and we are going to record. We are going to record this. What is the starting index? We are going to do I minus j. We are going to record the starting index. What is I? I is here. What is I? 0, 1, 2, 3, 4, 5, 6, 7, 8. I position is 8 and j position is what? 0, 1, 2, 3, 4 and 5. I minus 8, which is what? Which is what? 8 minus 5, which is 3. So the starting index which matches, right? It is 3. It is 3. So how it is 3? So 0, 1, 2 and 3, right? From this particular index, we had found a match, onions, right? So we are going to record this 3. Okay, we are going to record this 3. So I hope you have got the intuition, right? I hope you have got the intuition. Okay. Now, okay, I hope you got the now. I think now first let's see the pseudocode or the algorithm to calculate. I've already explained this, but there's some part which is remaining which I need to explain. Let's quickly see that. Okay. So let's see an example. Okay. So let's take A, B, A, and A and C. Okay. So let's see how to compute the LPS array. Okay. So this is A. Okay. So let's say we have this is, you can say, a pattern string. Okay. Now, what we're going to do, we are going to follow the similar algorithm which we have followed here. Okay. So what we're going to do is, let's say we have a J here. Okay. J. And let's have this corresponding LPS array. We want to compute the corresponding LPS array, right? So here, for example, so initially we consider the first, for example, if it is a single character, we are going to consider its LPS as 0. Okay. And we'll initialize our J, will have our J pointer here and our I pointer here. Okay. Now we are going to match here. J and the characters at J and I position. Are they matching? Yes, they are matching. So what we are going to do? We are going to write J plus 1 here. J is 0, 0 plus 1, 1 here. So what we are saying is out of this substring, right? So we have found a LPS of 1, basically LPS of 1, wherein this character is matching, both the characters are matching. Okay, so in this case where the characters are matching, we are going to increment both I and J. So J will be pointing here, I will be pointing here. Now we're going to compare the characters at I and J position. Are they matching? No, they are not matching here. Okay, no, they are not matching here. So in this case, what we are going to do? In this case, what are we going to do? So generally our intuition, let's say our intuition is going to be that let's reset J. Let's reset back to back where it was, right? Back where it was. So for example, let's take, for example, now that we have resetted J to from start. So we're going to compare now. Are they both matching? And let's say, yes, we reset this. We reset this. Okay, J and I is also incremented. And here we say when there was a mismatch, here we say there's no matching. So we are going to write 0 here. Now we're going to compare A and A, right? This I and J. So is it right to compare I and J? Because the continuity has already broken here, right? So is it right to compare I and J? Let's say we also compare I and J here. I and J. So they both match. Let's say now, so we write J plus 1 here. 0 plus 1, 1. That is one character matching. That is longest prefix is of size 1. Okay. Now we increment our J. Okay, we increment our j here, j is here now, and I is here. So we're going to compare. We're going to compare here. So this both are matching. A and A both are matching. So what are we going to write? J plus 1. So we're going to write j is what? 1. So 1 plus 1, 2. Okay. Now we're going to increment again. I is pointing here. Our j is pointing here. Okay. Now what do we say? We're going to compare this B and A, the characters at I and J position. No, they are not matching here. They are not matching here. So what are we going to do here? Okay, so what we're going to do here? For example, let's say, uh, let's say that we, according to our initial intuition, right? So if we reset J again to here, right? Again here. So our J is pointing here and our A is pointing here. Now, if we compare these two characters and if we say, okay, they're matching, so we are going to do J plus 1, which is 1. Is it right? Is it right to say that, okay, it is of size 1? No, it is not size 1. If you see, right, AA, it should be size of 2, basically. So the prefix and the suffix of size 2 are matching, right? But here what we're writing, it is 1, right? It is 1. So our initial approach to every time there is a mismatch to reset J to 0th position, it's not correct. Let's quickly see here, right? So what was the string? AAA, right? AAA. And what is this string? AAB, AAB. So we found that I was here and J was here. So they were not matching. So what we did, we we tried to match this. We reset J to this particular position, and then we were matching, which was not right, right? Our J should have been here, right? Our J should have been here, and it should have matched here, basically. Okay, which it should have matched here. And then we would have said that, okay, the longest prefix and longest suffix is this, basically, right? So in this case, instead of resetting our J to here and matching here, in this case, we will do the same thing what we did here, right? We did here. So what we are going to do here, LPS of J minus 1. Okay, J equal to LPS of J minus 1. What is J? What is J? J was here, right? J was here, right? J was here, which is 2. So LPS of J2 minus 1, which gives LPS of 1. LPS of 1 is nothing but this one, right? LPS of 1 is nothing but this one. So we are going to have our J, LPS of 1, which is 1. We're going to have J equal to 1, right? J equal to 1. So our J should be here. Now our I is here. So we are going to compare this and this particular A, this and this particular A. So which is what? J plus 1. The characters are matching. We're going to say J plus 1, which is 1 plus 1, which is 2. 1 plus 1, which is 2. So we are going to follow this approach, whatever we are going to follow this intuition in order to compute our LPS. Okay. So I hope you have got the intuition. Okay. I've tried to make it easy for you. So before going to, I think you'll understand better with the code. Okay. So before going to the code, I'll just request you to please subscribe to the channel, like the video. Okay. So I think you'll understand better with the code. So first, I'll show Java code followed by C++. Not much difference between the two codes. So let's compute our LPS first. Okay. First of all, let's take the length of pattern and text. First of all, we are going to take the length of text. Okay. Length. And then we have our pattern. M equal to pat dot length. Okay. Then we are going to have our LPS array, which will be of size pattern length, right? M. Now let's compute. Let's pass pattern, then LPS, and then the size of LPS array. Okay. Compute LPS, we'll say. Let's call it compute LPS. Okay. Then we have our compute LPS string pat, comma, int LPS, comma, int M. Okay. Now what we're going to do here is, let's have our J pointer, which will be 0, our I pointer, which will be 1, right? And what we're going to do while I is less than M. Okay. Now what we're going to do here, if uh, pat dot char at I, if it matches pat dot char at J, right? If it matches, then what we want to do? LPS of I. equal to LPS of I equal to j plus 1, right? J plus 1, then we're going to increment our j as I've already explained and increment our I as well, right? Okay, if there's no match, then what we're going to do? J equal to LPS of j minus 1. I've already explained this. Okay. But we are going to do this step only if j is not equal to 0, right? If j is not equal to 0, then only we are going to do this step. Else, what are we going to do? LPS of I, we are going to say it is 0. And we are going to increment our I, right? We are going to increment our I. So this is the compute LPS step. Okay. Now let's calculate. Let's do the pattern matching algorithm now. So what we're going to do? We are going to take again two variables, int I equal to 0, int j equal to 0, and we're going to run this till I is less than n, right? That is the size of the text. Okay. Now what we are going to check here? Text dot char at if it matches pattern dot char add j, then simply we are going to just increment I and plus plus j. Simply we are going to do that. If they don't match, then what we're going to do? Else if j is not equal to 0, then j is not equal to 0, then we have already j LPS of j minus 1, right? Else, what are we going to do? If j is already 0, then we're just going to increment I plus plus I. Okay, to compare the characters at zeroth position, like zeroth position of pattern and the next I position of text string. Okay, suppose this is done. For example, if j reaches size of m, that is a pattern length, then we have found a match, a pattern match. Then simply what we're going to do? Let's have a resultant array list integer result equal to new array list. Okay. And what we're going to do? Result dot add I minus j. So we have found a starting index and we want to go back, right? Now we want to find out the next occurrence of the pattern. Then we're going to, what we're going to do? LPS of j minus 1. That's what we're going to do. So in this way, we'll find all the occurrences of the pattern matching. And finally, what we're going to do? Return result. Okay. So let's compile this. So I hope you have got the solution. Okay. Let's submit it. Okay, the test cases are running. Please don't forget to subscribe to the channel, like the video. Let's quickly see the C++ code as well. While it runs, let's go through. Okay. Okay, maybe the code is almost same. Okay, I'll attach the code in the comment section, both C++ and Java. Okay, don't worry. Okay, thank you so much. Thanks for watching. Please subscribe to the channel, like the video. Have a happy, healthy, wealthy, and a great day. Thank you so much.